Have you ever wondered how organizations protect sensitive information like employee salaries, customer records, healthcare data, and financial reports? Every day, thousands of employees access company data, but not everyone should see everything. Let's say Sarah works in HR, David works in finance, and John works in IT. All three need access to same employee database, but should they all see the same information? Of course not. Sarah in HR may need access to salaries and employee records. David in finance may need salary information, not personal employee details. John in IT may manage the system but doesn't need access to confidential salary data. So, how do modern organizations automatically control who see what? That's exactly what we will explore today. Welcome back to Data World of Shashanka. In this video, I will show you how Databricks Unity Catalog uses attribute-based access control or ABAC to automatically give each user access to exactly what they need and nothing more. We will look at data classification, tagging, policy evaluation, data masking, governance, and finally build a working Databricks demo so you can see ABAC in action. Let's start with the foundation of data governance. Data classification. Before we can secure data, we first need to understand what type of data we have. Now all data is created equal. For example, phone number, email addresses, and date of birth are considered personal identifiable information or PII. Employee records belong to HR data. Salary information belongs to finance data. Healthcare records are highly confidential, and organization also have internal business information that should only visible to authorized user. The first step is to classify the data based on sensitivity and business purpose. Once the data is classified, we apply tags. Think of tags as labels attached to data. For example, phone number receives a PII tag, salary receives a finance tag, employee record receives an HR tag, healthcare record receives a confidential tag. These tags helps the system understand what type of data is dealing with. Without classification and tagging, the system cannot make intelligent security decisions. So, data classification and tagging from the foundations of modern data governance. Now let's move to the heart of ABAC. This is the attribute engine. Every time someone requests the data, Databricks evaluates a set of attributes before making an access decision. Think of this is an engine as a smart security guard. Before allowing access, it asks three important questions. Who is the user? What data they are requesting? And what policies they are applied. Let's start with user attributes. User attribute describe the person requesting access. For example, David works in finance. His attributes might be department equals finance, role equals analyst, location equals Sydney. Now let's look at a resource attributes. Resource attributes describes the data being requested. For example, salary data may have a finance tag, employee records may have a HR tag, healthcare records may have a confidential tag. Now we combine with policies. Policies define the business rule. For example, finance users can access finance data, HR user can access HR data, IT users cannot access salary information. Databricks evaluates three attributes together. If everything matches, access is granted. If not access, it is denied or restricted. The best part is the happen automatically. Every single time query runs. No manual approval, no manual intervention. Everything happens dynamically in real time. And that's what makes a ABAC so powerful. Now, let's look at one of the most practical features of ABAC, data masking. Sometimes users need to access to a table but should not see sensitive information. Instead of denying access completely, we simply mask the values. Let's look at an example. Suppose we have an employee table. One column contains four numbers. The original value might be 986754321. An HR user sees the full value, but an IT user may see star 321. The same thing can happen with the salary information. An HR manager may see the actual salary and IT user see a masked value instead. Notice something important. Both users are querying the same table. The difference is not the table. The difference is policy applied to the user. This allows organization to share data safely while protecting sensitive information. It improves security, support complaints, and reduces the need of creating multiple copies of same data set. Now we arrive at the brain of the entire system, the policy engine. This is where the final decision is made. Policies define who can access what. Let's look at a simple example. If the user department in HR and data is tagged as HR data, then allow access. Now another example, if user department in IT and data is tagged as finance data, then deny access. Organizations can create much more advanced policies. Policies can evaluate department, role, location, business hour, security clearance, data classification, sensitive level. Every request results in one or three outcomes: allow, deny, or mask. The policy engine evaluates these rules dynamically at runtime. Users don't request to permission every time. The system automatically makes the decision based on attributes and policies. This is what allows ABAC to scale across thousands of users and dataset while maintaining strong security and governance. Now we arrive at the final piece of the puzzle, the Data Governance Command Center in Databricks in a Unity Catalog. Think of Unity Catalog as the control tower of an airport. Just as a control tower monitors and controls all aircraft movements, Unity Catalog monitors and governs all data access across the organization. Everything is managed from one central location. Unity Catalog helps organizations discover data and classify data, apply tags, manage governance policies, monitor access, and perform auditing. Instead of managing security separately across hundreds or even thousands of tables, everything can be controlled centrally. This makes governance much easier and more scalable. For example, a new finance table is created and tagged correctly. Existing ABAC policy can automatically apply without any additional configuration. Unity Catalog also provides complete visibility into data usage. Organizations can answer important questions such as who accessed the data, when was it accessed, which table was accessed, which policy was applied. This level of visibility is critical for compliance, risk management, and security monitoring. It helps organizations meet regulatory requirements such as GDPR, HIPAA, and internal governance standards. The biggest advantage is consistency. Instead of everything implementing security differently, Unity Catalog provides a single source of truth for governance. Data remains secure, policy and remains centralized, and access remains controlled. Now we understood the complete governance architecture. Let's jump into the Databricks and see how ABAC works in real-world demo. Before we jump into the Databricks implementation, let me quickly explain the project we are building. The goal of the project is to demonstrate dynamic attribute based on access control or ABAC using Databricks Unity Catalog. In the real enterprise environment, organizations have different user groups such as HR, finance, IT managers, and executives. Each group should have access only to the data required for their role. For the demonstration, we will secure employee records containing personal identifiable information, finance data, and health information. We use several Unity Catalog governance features, including governance tag, column masking, and row filters. Our project consists of 4 components. First, data classification tags. We will classify the columns based on sensitivity, such as PIA and financial and PHI data. Second, column masking. Sensitive values like salary, phone number, and health information will be dynamically masked depending upon the user role. Third, row-level security. General employees will only see records for their own department, while HR and executives will be able to see all records. And finally, dynamic dashboard. We will create the Databricks visualization directly on top of the secured table and watch them automatically adapt based on user permission. Now, because I am running on the demo as a single user, I don't have multiple activity directory or Okta users available to test with. So instead, I use a simple simulation approach. We will create a session variable called simulation role. This allows me to switch between HR, finance, IT, and executive views with the same Databricks session. This is purely for demonstration purpose. In the real production environment, Databricks would use the actual user identity groups and permissions for your organization's identity provider. We will also create a dedicated schema called employee security demo and populate with a sample employee data. To make the demo easy to run, I will either load a CSV file one exists in Databricks volume or automatically generate employee data using a Spark so that anyone can use the project immediately. By the end of this demo, you will see how Databricks Unity Catalog can dynamically control access to data using ABAC, all from a single governed table without creating a multiple copies of the data. I am creating a dedicated workspace for the demo. The code connected to Unity Catalog creates a schema called ABAC demo schema and makes it active. This gives an clean place to store all the tables and security objects we will create during the demo. Here I am creating a sample employee data for demo. The table contains employee details, salary information, contact details, and health information. I am loading the data into Spark data frame and saving it as a Delta table called Employee Security Demo. This table will be used throughout the demo to test our ABAC security policies. Since I am the only one person in Databricks account, I need to wait to simulate different users. This code creates a configuration table to store a simulator role such as HR, Finance, IT or Executive. Then it creates a function called getSimulatorRole that tells Databricks which role I am currently presenting to be. Later, our security policies will use this role to decide what data can be seen and what data should be hidden. Here I am creating masking function for sensitive columns. Salary is only visible to HR, Finance and Executives. Phone numbers and addresses are only visible to HR and Executives. Date of birth is protected. Medical information is also protected. When user query the table, these functions automatically decide whether to show the real value or a masked value based on the user role. The same table is used for everyone, but different users see different results. Here I am creating a row filter function. Unlike masking, which protects individual columns, row filters control which records users can see. HR and executives can see all employee records. Finance users can only see finance employees. IT users can see only IT employees. Databricks automatically applies the filters whenever a query runs, ensures users only to see data relevant to their roles. Here I am attaching the masking function and row filter to the employee table. Salary, phone number, address, date of birth and the medical information are now protected by masking policy. The row filter is applied to the department column so users only see records they are allowed to access. The data itself doesn't change, only what each user sees changes. Now we are ready to test ABAC solution. So far we have built the security framework. Now let's test it. I am switching my simulated role to HR. Remember, in the real organization, Databricks would use Activity Directory or Okta groups. Since I am only one user, I am simulating the different roles. Right now I am pretending to be HR manager. When I query the employee table, HR should be able to see all employee records. HR should also be able to see sensitive information such as salary, phone number, addresses, date of birth and medical information. Let's run the query and verify the results. Notice that all the rows are visible. Notice that no columns are masked. This confirms our row filters and masking policies are working correctly for HR user. Next, we will switch to finance and IT users and compare the results. The interesting part is that we will querying the same table. We are not creating separate tables. We are not duplicating data. The security policies automatically decide what each user can see. Now I am changing the simulated role to finance. Finance users should only see finance department records. Salary information remains visible because finance needs it for their job. However, personal information such as medical data may be hidden. Let's run the query and see the difference. Now I am switching to an IT user. IT manages systems and infrastructure but doesn't need access to confidential employee information. Let's run the same query again. Notice that salary information is hidden, phone numbers are masked, medical information is masked, and only IT department records are visible. The same table is being queried, but the results are completely different based on their user role. This is ABAC in action. Today we learned how Databricks Unity Catalog uses ABAC to protect sensitive data through governed tag, column masking and row level security using a single table. We were able to provide different level of access for HR, finance and IT user. This is exactly how modern organizations balance security and compliance and accessibility. If you enjoyed the video, don't forget to like, subscribe and share. Thank you for watching Data World of Shashanka and I will see you in the next video.